Imagine standing under the relentless sun of the ancient African savanna millions of years ago. Around you, the landscape bakes under a sky that offers no mercy and no shade. Your body is covered in a thick coat of dense fur that traps every degree of rising heat. For millions of years, that furry coat served your primate ancestors perfectly well in the cool shade of forest canopies. It protected tender skin from sharp thorns, biting insects, and freezing nocturnal winds. But as the dense forests shrank and gave way to vast open grasslands, the climate forced a radical choice. Stepping out into the open sun meant entering an oven where every movement generated internal heat. Most mammals handle high temperatures through a simple biological mechanism known as panting. A heavy dog or big cat sits in the shade, opening its mouth to exchange heat through rapid, shallow breaths. That strategy works brilliantly while resting under a leafy branch during the quiet afternoon hours. It becomes completely useless when you are actively moving across miles of sun-baked terrain. Panting restricts breathing rhythm and makes long-distance physical effort nearly impossible. Early hominins were beginning to walk on two legs, stepping away from tree branches into an active lifestyle. Bipedalism reduced the surface area of the body exposed to direct overhead sunlight, yet it also demanded sustained physical exertion during the hottest hours of the day. As these early ancestors walked longer distances, their metabolic engines generated immense internal thermal energy. The most vulnerable organ in this rising temperature crisis was the newly expanding human brain. Brain tissue is notoriously sensitive to excessive heat and fails rapidly if temperature spikes even slightly. A few degrees of fever or overheating can trigger confusion, organ failure, or fatal heat stroke. Evolution was faced with an urgent biological crisis that demanded an immediate engineering solution. If our ancestors were going to survive in the open sun, they needed a revolutionary cooling mechanism. Nature did not invent an internal air conditioner or grant us reflective metallic skin. Instead, it tapped into an ancient secretory system already present in mammal skin. Human skin is packed with millions of microscopic structures known as eccrine sweat glands. Most mammals possess these glands only on the pads of their paws for grip and friction. Hominins multiplied these glands across almost every square inch of their exposed body surface. When internal temperature rises, these glands pump out a watery liquid composed mostly of water and salts. As that liquid water evaporates off the skin surface, it absorbs latent thermal energy from the body. Heat flies off into the surrounding atmosphere, dropping internal temperatures back down to safe levels. It is one of the most efficient thermal regulation systems ever developed in the history of animal life. A conditioned human can sweat up to 12 liters of water in a single scorching day. This evaporative cooling system gave early humans a superpower no other African predator possessed. While lions and cheetahs overheated and collapsed into the shade after short explosive sprints, humans could keep walking. We became endurance runners, chasing prey across endless miles until the animals simply dropped from thermal exhaustion. But this brilliant sweating mechanism came with an enormous, unavoidable physical requirement. Sweat cannot evaporate efficiently if it gets trapped inside a thick mat of dense hair. A furry animal that sweats merely ends up soaked in warm, stagnant moisture that insulates heat rather than releasing it. To make evaporative cooling work effectively, the thick fur coat had to go. Over hundreds of thousands of years, genetic mutations gradually reduced the thickness and length of human body hair. We did not actually lose our hair follicles, we simply altered the hair follicles themselves. Humans have roughly the same density of hair follicles on their bodies as chimpanzees do. The difference is that human body hair transformed into microscopic, almost invisible vellus hair. Strip away the thick fur, and suddenly the skin became a bare, high-performance radiator. Sweat could now coat the skin in a thin sheet and evaporate instantly into the dry breeze. Our ancestors had traded their natural winter coat for an elite thermal management system. Yet in the relentless game of evolution, every major upgrade arrives with a steep price tag. The loss of fur solved the heat crisis, but it instantly exposed bare skin to a dangerous universe. Without fur, living tissue was suddenly vulnerable to the intense solar radiation of equatorial Africa. Powerful ultraviolet rays began penetrating directly into unprotected skin cells, causing cellular damage. Solar radiation breaks down essential nutrients like folate, which is critical for reproduction and cell division. Unprotected skin is also easily scratched by thorny bushes, bitten by venomous insects, and scraped by rocks. Night times in the African wilderness brought a second unexpected punishment for the newly naked apes. Grasslands lose heat rapidly after sunset, dropping temperatures to shivering lows before dawn. Fur had kept our ancestors warm during frigid nights without requiring extra energy. Without that protective insulating layer, early humans began losing vital thermal energy into the cold night air. The loss of hair forced our ancestors to find clever behavioral workarounds to survive the night. They began huddling together tightly inside caves, sharing body heat under the dark sky. Eventually, the mastery of fire provided the ultimate artificial blanket to replace lost fur. Fire kept predators away while filling the thermal gap left behind by our hairless bodies. Meanwhile, the daytime solar radiation crisis demanded an immediate biological response on the skin surface. Skin cells called melanocytes began producing large amounts of a dark pigment known as melanin. Melanin absorbed incoming ultraviolet radiation like a natural shield, protecting fragile DNA underneath. Darkly pigmented, hairless skin became the standard uniform for early humans living near the equator. It was a delicate, complex compromise between sweating efficiency and radiation defense. But why did evolution leave hair on certain isolated regions of the human body? Consider the thick canopy of hair remaining on top of the human head. When standing upright under the tropical sun, the top of the scalp receives the most direct solar energy. Tightly curled or thick hair on the head acts as a natural sunshade for the brain case. It traps a pocket of air above the skull, preventing solar radiation from baking the delicate brain underneath. At the same time, it allows sweat on the scalp to evaporate through the loose airspace. Hair under the arms and in groin regions served different evolutionary functions. These areas experience constant physical friction during long-distance walking and running. Hair in these joints acts as a natural lubricant, reducing painful skin chafing during movement. It also traps specialized chemical signals, known as pheromones, aiding in social and sexual communication. Facial hair in males may have played a role in visual signaling, dominance displays, or sexual selection. Every remaining patch of hair on the human body serves a specific historical memory of survival. As hairlessness became fixed in human genetics, it triggered massive cultural and social transformations. Without fur to cling to, human infants could no longer ride securely on their mothers' backs. Baby primates grab onto their mother's thick hair with strong hands and feet while the mother moves. Human babies were born helpless, smooth-skinned, and unable to cling to smooth skin. Mothers had to carry their babies in their arms, restricting their ability to forage for food alone. This physical limitation demanded greater cooperation and support from the entire social group. Fathers, grandmothers, and siblings had to step in to help carry and protect defenseless infants. The loss of fur effectively forced humans to develop deeper social bonds and cooperative parenting. It also spurred the invention of baby slings made from animal skins and woven plant fibers. To replace lost fur, early humans began skinning hunted animals to wear their pelts as clothing. Tailored clothing allowed our species to expand beyond warm tropical zones into freezing northern environments. A hairless body clothed in removable furs proved far more adaptable than a body permanently trapped in one coat. When it was hot, clothing could be removed to allow efficient sweating and rapid cooling. When it was cold, layers of animal pelts could be added to trap dead air and retain body heat. This behavioral flexibility turned humans into the most adaptable large mammal on the planet. Hairlessness also changed how humans communicated and interacted with one another visually. Fur hides subtle shifts in blood flow, muscle movement, and emotional expression on the skin. Bare skin allowed humans to see flushing, blushing, pale fear, and subtle emotional cues on the face and body. Non-verbal communication became immensely rich, enhancing empathy and emotional connection within groups. Social grooming also underwent a dramatic evolutionary transformation. Primates spend hours picking parasites and debris out of each other's fur to maintain social bonds. When fur vanished, picking through hair was replaced by touch, massage, decoration, and verbal conversation. Language may have expanded partly to fill the social bonding void left behind by physical grooming. Bare skin also made humans uniquely sensitive to external touch and subtle temperature changes. Our skin became a massive sensory organ packed with nerve endings that read the surrounding world. Every breeze, drop of rain, and gentle touch became instantly perceptible to our ancestors. Yet the battle against parasites took a strange and unexpected turn when fur disappeared. You might think losing fur would completely eliminate external pests like fleas and lice. Instead, human lice adapted to the new landscape, splitting into two distinct specialized species. Head lice stayed safely entrenched in the dense hair on top of the skull. Body lice evolved specifically to live inside human clothing, clinging to fabric fibers instead of hair. Genetic studies of lice speciation even help scientists pinpoint exactly when humans began wearing clothes. The timeline of lice evolution suggests tailored clothing emerged roughly 100,000 years ago. Every aspect of human biology carries traces of this ancient thermal transition. Consider the immense water requirement demanded by our high-performance sweating system. A sweating human quickly becomes dehydrated if clean water is not consumed regularly. Other savanna animals can go days without drinking, relying on moisture from their food. Early humans were tethered to freshwater sources, shaping ancient migration routes along rivers and lakes. We had to invent water containers made from dried gourds and ostrich eggshells to carry water across distances. The loss of fur drove technological innovation just as much as it drove biological change. As humans migrated farther from the African equator, the sweating balance shifted once again. In colder, darker northern latitudes, dark melanin in hairless skin became a major handicap. Sunlight was too weak to trigger adequate vitamin D production through heavily pigmented skin. Natural selection began favoring lighter skin tones in northern populations to let scarce UV light penetrate. Thus, the story of skin color is directly linked to the original decision to abandon body hair. First, we lost our fur to keep our expanding brains from overheating in the African sun. Then, we developed dark skin to protect our naked bodies from dangerous solar radiation. Finally, we adjusted skin pigment levels as we migrated into different light environments across the globe. None of these changes would have happened if we had remained covered in thick primate fur. Look closely at your own skin during a hot summer afternoon or a challenging workout. As tiny beads of sweat form on your forehead and arms, you are witnessing an ancient evolutionary marvel. That moisture is the reason your ancestor did not collapse on the African plains 3 million years ago. It allowed early hominins to outrun gazelles, outlast apex predators, and explore open horizon lines. It kept the delicate neural circuitry of our expanding brains cool enough to think, plan, and innovate. Modern humans often view body hair as a cosmetic annoyance or a grooming hassle. We buy razors, waxes, lasers, and creams to remove the tiny remnants of hair that remain. We spend billions of dollars trying to maintain smooth, hairless skin across our bodies. In doing so, we are ironically continuing an evolutionary trend that began millions of years ago. We are obsessed with smooth skin because our species built its entire identity around being naked. Yet we also spend billions of dollars on antiperspirants to stop the very sweating that made us human. We sit inside air-conditioned rooms, avoiding the sun that shaped our sweat glands in the first place. We wear synthetic clothes that mimic the insulating properties of the fur we spent millennia losing. We have created an artificial environment designed to protect our delicate hairless bodies from nature. But under all our clothes and modern luxuries, our biology remains suited for the ancient savanna. Our skin still expects us to run under the sun, sweat profusely, and drink cool river water. It still expects us to gather around fires at night to stay warm under freezing starry skies. Every pore on your body is a testament to a grand evolutionary trade-off made long ago. We sacrificed the safety of a permanent warm coat for the freedom of high-end endurance. We chose a vulnerable exposed skin surface so that our brains could grow without burning out. That trade-off made us fragile, cold at night, and easily injured by the sharp edges of the world. But it also made us creative, cooperative, and capable of inhabiting every corner of the earth. The loss of fur was not a random genetic mistake or a cosmetic accident of nature. It was a masterclass in biological compromise, where one weakness was swapped for a greater strength. In the long story of life, species rarely get something for nothing. Every adaptation requires giving up an existing advantage to gain a new capability. Birds gave up heavy teeth and strong front limbs to gain the lightness required for powered flight. Whales gave up walking on land to conquer the vast depths of the open oceans. Humans gave up thick protective fur to gain the ultimate thermal cooling system for an active brain. When you feel a cold draft on your bare arms, you are feeling the cost of that ancient decision. When you pull a warm sweater over your head, you are completing an evolutionary arc millions of years in the making. You are using culture and technology to replace the natural insulation your ancestors threw away. Science allows us to look back across deep time and reconstruct these incredible transitions. We can examine ancient fossilized skeletons and analyze subtle markings on bone structure. We can sequence modern genomes and track the exact mutations that quieted our hair growth genes. We can study the microscopic structure of skin cells and measure the efficiency of sweat evaporation. Every scientific clue points back to the same fundamental story of adaptation and survival. Nature does not work toward a pre-planned ideal or a final perfect form. It works through immediate pressures, testing whatever random variations appear in each generation. Those individuals whose bodies handle heat slightly better live long enough to pass on their genes. Those who overheat in the afternoon sun leave fewer descendants behind on the dusty ground. Generation by generation, the gene pool shifts, reshaping the outer appearance of the entire species. The furry forest ape slowly transformed into the sleek, hairless savanna runner. This transformation altered not just our physical bodies, but our psychology and social structures. It forced us to look at one another face to face, reading emotions directly on exposed skin. It made us depend on communal warmth, shared fire, and cooperative hunting strategies. It turned a weak, hairless primate into a master of tool-making and environmental modification. Without losing our fur, we might never have needed to invent clothing, shelter, or controlled fire. Without sweat glands, we might have remained trapped in the shrinking, shaded forests of ancient Africa. Our entire civilization is built on the foundation of our bare, sweating, heat-regulating skin. It is humbling to realize that our species' greatest achievements began with a simple problem of overheating. Cincinnati halls, space travel, literature, and philosophy all trace their roots back to sweat droplets. They were born because an ancient ape needed to cool down its expensive expanding brain. The next time you step out into a hot afternoon and feel sweat break out across your forehead, pause for a moment. Do not reach immediately for a towel or complain about the uncomfortable humidity. An ancient evolutionary shield keeping you alive, it is the signature of your species, a biological inheritance handed down through tens of thousands of generations. It is proof that your ancestors walked across scorching valleys and survived where others perished. You carry their history in your DNA, in your sweat glands, and in your bare skin. You are the product of millions of years of negotiation between biological heat and solar light. Our bodies are walking archives of every environment our ancestors ever inhabited. The shade of the ancestral forest, the glare of the open grassland, and the freeze of northern ice ages are all recorded here. They are written in the density of our sweat glands and the subtle distribution of our body hair. They are written in the pigment of our skin and the structure of our hair follicles. Understanding this history changes how we view ourselves and our place in the natural world. We are not separate from nature, nor are we exempt from its physical laws and trade-offs. We are subject to the same evolutionary forces that shape every creature on this planet. Our hairlessness is not a badge of superiority or a mark of biological perfection. It is simply a specialized tool that allowed a vulnerable ape to solve a specific environmental challenge. It reminds us that every advantage in life comes with a corresponding responsibility and cost. To stay cool, we must drink water. To stay warm at night, we must build shelter and seek community. To protect our naked skin from the sun, we must use our minds to invent external protection. Evolution gave us the physical setup, but it left the daily management up to our intelligence and culture. That dynamic interplay between biology and culture is what truly defines the human experience. We are biological creatures who use culture to patch the gaps left behind by natural selection. We wear jackets because we lost our fur. We build houses because we lost our thick insulation. We tell stories around fires because we needed to huddle together against the nocturnal chill. Every cultural invention is a creative response to an ancient biological trade-off, and as we look into the future, our bare skin will continue to adapt to new environments. Whether we move into crowded megacities or travel beyond the atmosphere into space, our biology will carry this legacy. We will still need to regulate our thermal energy, protect our fragile cells, and stay connected to one another. We will still rely on the same fundamental sweating mechanism that saved our ancestors long ago. So why did ancient humans lose their fur and master the art of sweating? because they dared to leave the shade of the trees and run out into the open sunshine, because they needed to keep their growing brains cool while chasing an uncertain future across the horizon. Because nature demanded a sacrifice, and our ancestors willingly offered their protective coats in exchange for endurance. They traded fur for freedom, insulation for intelligence, and safety for boundless adaptability. It was a risky, dangerous gamble that could have easily led to thermal extinction, but it succeeded beyond any reasonable expectation, turning a vulnerable ape into a global species. The story of human hairlessness is the story of how a single trade-off reshaped the world. It shows us that true strength does not come from having thick armor or sharp claws. It comes from the ability to adapt, to cool down under pressure, and to find creative solutions to lethal problems. Our naked skin is a badge of honor, forged in the heat of the savannah and refined over millions of years. It connects every single human alive today to a shared lineage of resilient, sun-baked endurance runners. Beneath our diverse skin tones, varied clothes, and modern cultures, we all share this same smooth canvas. We are all descendants of the naked apes who learned to sweat, run, and survive under the African sun. And whenever you feel the heat of the sun on your bare shoulders, remember where you came from. You are standing on the shoulders of ancestors who walked away from the shade into the light. They lost their fur, gained their endurance, and left you with a biological miracle wrapped around your bones. Nature gave us sweat instead of fur, and in doing so it set us free to walk the earth.